Okay, on to 23 through 25. This is actually a very long group study, but we're getting through it, almost there. Here we see another multi-step. This one here, oh my goodness, this may be identical to what's on the test. You never know, but here we have a reaction from last semester. In the first one, I'm going to do this on a sheet of paper before looking at the answers and getting tricked myself. Here in this first step here we have a radical reaction where we're going to have a bromine radical form. This is a reminder. It's going to come along and abstract that hydrogen. What it does is it can abstract the hydrogens here. And I may have goofed on this one here. This one could also get abstracted here, but we're not going to pay attention to that. Let's ignore that one right there for now. Let's assume that the problem is correct. And the intended outcome was to abstract this hydrogen here, so that in the next step here, this is the propagation step for a radical. When we're showing radicals, we do the fish hooks, and we're going to abstract out that a bromine from that, and we make this. Okay, all we did that for is to carry out an SN2 reaction. Again, KCN means that we have this negative charge that's going to carry out a backside attack. Bromine is now a leaving group right here, and we get this molecule. Whoa, my hand's going crazy. So all of that just to substitute a little CN. Go back here. Next two reactions are a reduction. When we reduce this right here, remember with amides and with cyano groups like this, the N stays when we do a complete reduction. So here's that 1 and 2 right there. The N is going to stay, and it's going to become an NH2. Right here. So keep track of the carbons. Here we have two carbons right here. Make sure those are there. There they are. Right there. I have no idea, that was totally out of the view there, but here we have the two carbons right here, and now we have 2 carbons right here with an NH2. That is the nitrogen from that source right there. Okay, now that we have an exposed nitrogen, that's very basic, and we can react this acid chloride with that. So in the last step here, we get this substitution right there. And there is the answer. So let's look at these answer choices here. The answer that I just drew here a minute ago should have been this one right here. It's got the 2 carbons in it, 1, 2, and it's got the right number of carbons in this chain right here. You want to make sure that's correct. Notice on this one there's a couple things wrong. One of them very sneaky. That is only 1 carbon right there. Sneaky, sneaky. But to actually make it a little bit more apparent for the student here, notice that that is not an OH right there. That should have been an OH that was on the other side of the ring. So that couldn't be an answer choice. And the others here do not leave the nitrogen. That's if you forgot that this lithium aluminum hydride carried out a reduction and did not result in an oxygen, OH, being present. Okay, so that's that one. Next one here. No. This is more like an MCAT type question where they want you to know the word phthalimid. If you had no idea what phthalimid spelled, then you wouldn't know that it is this compound down here. That's phthalimid. Right there, didn't even have to draw it. But the net result of a phthalimid is to take, so we got a butyl group here, 1, 2, 3, 4, is to take this halogen right here and change that into an NH2. That's all that we have to do here. It's just putting an NH2. There's only one answer choice with that. C is the only one where we'd have a butyl group attached to an NH2. Last one here, a little bit tricky. Sometimes I throw in some drug chemistry onto the test. We got a new and interesting one tomorrow. But on this particular one here, it's a retrosynthesis, so you look at a complicated drug molecule, morphine here, and then you look at the product of this, say this is a derivative in a synthesis, a multi-step synthesis that they're going to transform, so it's intermediate. And you have to see what's different with this complicated molecule. What's different is we have an extra methyl group on a nitrogen. There's only one methyl group here. That should alert you to that double bond being present. That means we carried out an elimination right here at that particular carbon. We learned in this chapter here we carry out an E2 Hoffman elimination here using our excess of methyl iodide, and you can see right there was an extra methyl group added, so we need to have that methyl iodide right there, and a little bit of silver, a little bit of heat. There's the answer. This one here is more complicated, I know, with a drug molecule here and transforming it like that. But if you observe that one extra methyl group right there, look, you could have gotten the right answer because nothing else has methyls in it right there. So sometimes I throw some breaks for you guys. But that's problems 23 through 25. What was that? Did you just cuss at me under your breath?